Okay, let me just share my screen. First of all, let me check if I'm visible or not. 1 second. Yeah, I think I'm visible. Let me just share my screen and read the problem statement. Yeah, I think it's visible now. Let me open today's question. Okay, not this one. Okay, this was the question. What is the question? I've already solved it once. Like it's also present in lead code. You can just go and see this question. Given an array ARR and an integer k, divide the array into k continuous. Okay. Those who don't know, let me just like tell you the approach to solve this problem. Rather than just checking, splitting, like making all the subarrays and checking the sum of all the arrays, what we do is we use something known as binary search. Okay, and where do we apply binary search? We apply binary search to the answer. Like we know that we have to maximize the sum of all the subarrays. Okay, so what is going to be the like a minimum uh, subarray sum? The minimum is going to be the maximum of one of them. Like suppose the value of k is 4. Okay, for this example the value of k is 4, so we are going to have subarrays of 1 elements. This will give us only the maximum value that we can have is 4. And suppose we have the value of k is equal to 0. What then? Then we have the maximum sum as the summation of all the arrays, which is all the elements of the array, 4 plus 3 plus 2 plus 1, which is going to be 10. Okay, so great. Binary search, we are going to apply binary search starting from the like the minimum element going to all the sum like present in the array, and we'll check for each and like for the middle element we'll check that it is possible to make k partitions or not. If it is possible to make k partitions, then just return that answer. If it is not possible to make k partitions, just like move to the next index. Okay, great. Let me just write this code. Int maximum element is equal to just ARR of 0, and int sum is equal to ARR of 0. Okay, for int I is equal to 0, I is more, and I plus plus. What I have to do, I just have to take maximum element is equal max of maximum element comma ARR of 0. Okay, same goes for sum plus is equal to ARR of I. Okay, I'll just start this index from 1. Now what? Mm, after this, after getting this, I'll just have to like start a binary search from like checking the mid and all. Okay, okay, great. uh, so uh, let's say int left is equal to maximum element, because I don't want to mix this code, right? Maximum element comma right is equal to, or high local high is equal to sum. Okay, So it is going to be low and high. Okay, great. What now? uh, while low is smaller than equal to high, what I have to calculate? I have to calculate mid is equal to low plus high minus low by 2. Okay, now here I'll just make a function in which I'll just check that it is possible to make k partitions from that element, that mid, or not. If it is possible, just return this only, and like keep it and check if there is any better solution than this or not. Okay, so I'll just write what if check, or if possible, take low comma mid comma, uh, we'll just take low comma mid comma, uh, uh, not low comma mid comma. Okay, I'll just take a double r comma k comma mid. Okay, now if it is possible, just keep answer is equal to mid, and answer is equal to mid, and uh, decrease your search space. Okay, so high is equal to mid minus 1. That's it. Mid minus 1. Great. If it is not possible, else low is equal to mid plus 1. That's it. And here just return answer, and here answer is equal to 0. Great. Now only thing left is to write the code for possible or not. Let me write it possible or not. It is sounding better. Possible or not. Okay. So it will be a bool function. Check possible or not. It will take 3 parameters. Comma indicate in. Okay, this is mid. Okay, I'll just name it, because partition is going to be around this element. Okay, so I'll just name it element. Now what? I'll just have to check for all the elements, right? So and count is equal to 0, comma answer is equal to 0, comma n is equal to a double r dot size. Okay, now I'll just check for each and every element. For and I is equal to 0, I is more than n, I plus plus. If a double r of I is greater than mid, okay, just increase the value of count and return false. Okay, if this is the case, just return false. Okay, it is not possible to make such divisions. True. If not, sum plus is equal to a double r of I. Also, if sum is greater than mid, just increase the value of count plus plus, and just take sum is equal to a double r of I. That's it. And here uh, just check if count is smaller than equal to k. If it is true, just return true, else return false. Okay, great. I think my code will work fine. Let me just try run this code first of all. Okay, its maximum element as 0, let's take the example of this one only. Okay, this example only. 1 2 3 4. Okay, the minimum element is the value of the maximum element is 4. The value of the minimum element is sorry, the sum is 10, right? So low is equal to 10, max high is equal to sum. Okay, why low is smaller than this? If it is possible, okay, the main thing is possible or not. Int count is equal to 0, answer is equal to 0, and is equal to double of sides. Find I is smaller than 0, I is smaller than I plus plus. If a double r of I is greater than mid, return false. It is not possible to do it. Sum plus is equal to double r of I. If sum is greater than mid, count plus plus. Sum is equal to a double r of I. Okay, great. The what is the count of sum? It was 0. Now it is 1. 2 plus 1 is 3. Sum is no. 2 plus 1, 3. 3 plus 3, 3 plus 3. 3 plus 3 is 6. Sum is equal to ठीक है. Okay, count is 1. Now 3 plus 4 is 7. Sum is 2. Okay, so how many? Okay, if it would have been 1. Okay, I have to also do here count plus plus. Okay, now let's check for this. Mid was not declared in this scope. अच्छा. Mid. Okay. Sum was not declared in this scope. Okay. N was not declared in the scope bag. Only a declaration part. Okay. No issues. It's simple. Okay, if possible or not declared in the scope. Check if possible or not. Wow, Darsh. Bro. Let me just name this checker. Okay. Is there any more compilation errors? Finally, there is no compilation error, just the no issues. Just submit this code and check if this is working or not. Yeah, it is working pretty fine and it passed all the test cases. So yeah, great. So let's get to some other question of lead code.